Now that we've read in the data as a data frame and checked to make sure that there are no missing values, we're going to proceed to the univariate analysis. First, we deal with the experience level column that contains 4 values: EN, MI, SE, and EX. We want to first replace the EN, MI, SE, and EX with the full name of the experience level. For EN, it's entry level. For MI, it's mid-level, and so on. I'm going to highlight all of this text, Command X, escape, A to add a new cell above, enter, and then Command V to paste it in a new cell because I want to run it independent of this code that I'm circling. So each one of these lines is going to replace values in the experience level column. It's going to take the experience level column and replace the matching string for EN with entry level / junior. And then the second line will do the same thing for MI and so on. So we're going to go ahead and run this code and expect that in the experience level column, instead of an SE, we will see a senior level / expert. And instead of the MI, we will see a mid-level / intermediate. So let's run this code. We see that check mark, so we know that we've run the code correctly. And now we're going to go ahead and reprint out the head of this data frame. And as we expected, the SE was replaced with senior level expert, and the MI was replaced with mid-level / intermediate. Now, we're going to make our first plot. Control D, to clear that extra space, and then we're going to go through this little plot build. X_level is going to be equal to the value counts in the experience level column. So as we read, this value counts method returns a series containing the counts of unique values. We know that in the column there are 4 unique values, so this will return a series of length 4 that contains the number of observations, rows, that are entry level / junior, mid-level / intermediate, and so on. And then we're going to hold those value counts, that series of length 4, in this X_level variable. And then we're going to pass that X_level variable as an argument in a plotting function. Now we'll explore this plotting function. So we're going to create a plotting variable called fig, for figure, that is equal to px. Again, px is the alias for plotly.express. So we're going to use the plotly.express library for this plot. And we're going to call the Treemap method. We're going to pass to it the X_level, which again is a series of length 4 that contains the unique value counts, or the value counts for each unique field. And then we're going to pass a path, that's the EX_level.index, and the values, which is the EX_level.values, and then a title. So first let's run this code, and then we'll look up the documentation to get a little bit more of an understanding for this path and values argument. Once we build the plot and save it as the variable fig, we can call the .show method to actually give us the plot. So we run this Treemap, and we see the title experience level corresponds to this line of code here, this argument in the Treemap method, title equals experience level. And then we see senior level / expert, mid-level / intermediate, entry level / junior, and executive level / director. Those are the 4 indexes. And then we see the counts equal to value. So in this case, for senior level expert, the value is equal to 2516. For mid-level / intermediate, the value is equal to 805. For entry level, the value is equal to 320. And for executive director, the value is equal to 114. Now this Treemap, as we see in this markdown here, gives us an idea of the relative frequency of occurrence for the different experience levels. And obviously we see that the senior level / expert experience level is by far the most common, followed by mid-level / intermediate, entry level / junior, and executive level at the last. Now this example code says that surprisingly, the executive experience level is the lowest frequency. And I would argue that that's actually not surprising. What is surprising potentially is that the senior level / expert is so much more common than the mid-level / intermediate. Now, as we discuss this little tree map, I notice maybe one or two potential criticisms. One is that this tree map is at first glance qualitative rather than quantitative. What I mean by that is that we can see obviously that senior level / expert is much more common than entry level / junior, but we have to hover in order to see what the number difference is. So we see 2516 for senior compared to 320 for entry level, but it's not immediately quantitatively apparent. So this tree map is potentially not as useful as a histogram. So we're going to consider changing this figure from fig equals px dot tree map to fig equals px dot histogram in order to give us a quantitative look from the beginning. So as we look at this px dot tree map, we need to explore a little bit of the documentation. And we can see here in this function that VS Code provides us already some of the documentation. It says that when we call the Treemap function or method, we can pass to it a data frame, names, values, parents, IDs, path, color, and on and on. There are many optional arguments, and we have actually only provided 3. We've provided a data frame-like object, a series, a path, and values, and I guess a title, so 4 arguments. Where else could we find this documentation? Well, we could just copy Command-C, Command-Tab, arrow, and then look at Google, Plotly documentation for px.treemap. And then we see Plotly, plotly.express.treemap documentation. And this provides us the same information as we saw in that highlighted piece in VS Code, but potentially in a little bit more detail and definitely on the web. So here's where we can look at this documentation and get very specific with how we want to make this plot. However, we probably don't actually want a tree map here. We most likely want a histogram.